to AQA 14.4 Electrochemical Cells. If you need to look at your textbook to help, then it's pages 208 to 211. Our lesson objectives for today are to appreciate that electrochemical cells can be used as a commercial source of electrical energy, to appreciate that cells can be non-rechargeable, rechargeable, and you can also have fuel cells. Use given electrode data to deduce the reactions occurring in non-rechargeable and rechargeable cells and deduce the EMF of the cell. Understand the electrode reactions of a hydrogen-oxygen fuel cell and appreciate that a fuel cell does not need to be electrically recharged, and appreciate the benefits and risks to society associated with the use of these cells. So firstly, introduction, what is a battery? So we use the term battery in everyday life to mean a portable source of electricity. However, scientifically, it means several cells joined together. There are three sorts of these. You can have non-rechargeable batteries, you can have rechargeable batteries, and you can also have fuel cells. So first of all, non-rechargeable cells. So the first example is a Daniell cell, which is shown in this diagram here, where you've got a zinc electrode, and the copper electrode is actually the copper can that contains the copper sulfate. So you've got two liquids, you've got the copper sulfate and you've got the zinc sulfate. So the zinc sulfate is in contact with the zinc electrode, the copper sulfate is in contact with the copper electrode, and then you have this porous pot which separates the two solutions. So the porous pot acts like a salt bridge in the fact that it prevents the two liquids from mixing, which can cause undesirable reactions, but it also at the same time allows free movement of ions. So ions can move from the copper sulfate to the zinc sulfate without the two liquids mixing together. So the electrons go from the most reactive metal, which is zinc, to the least reactive metal, copper, and this causes a current to flow. Now the major disadvantage of the Daniell cell is that the liquids can leak from the Daniell cell, and because they have toxic and irritant, then this is obviously a bad thing. So another example of a non-rechargeable cell is the Leclanche cell, which is an improvement on the Daniell cell. It's shown in this diagram here, and it's the basis of most ordinary disposable batteries. So most day-to-day disposable batteries you have around your house will be Leclanche cell. So it's similar to the Daniell cell in that it involves zinc, but the difference is it's got the electrolyte is a paste rather than a liquid, and this is important because it's a paste. It means it's less likely to leak. So it means if you do get a compromised outer casing, then you're less likely to have a leak of the corrosive liquid. So the half equations are shown on the slide. It's zinc to zinc 2 plus with 2 electrons, and that gives you a voltage of minus 0.8 volts. And then you've got the ammonium ion plus 2 electrons to give ammonia and hydrogen. And I apologise there, the 4 should obviously be subscript rather than superscript. And that gives plus 0.7 volts. So overall this gives 1.5 volts, with the zinc being the negative terminal. So to get the overall voltage here, it's the difference between the two voltages, which is 1.5. Now, the eagle-eyed amongst you will notice, if you look in your electrochemical series, that those values are different to what is in the electrochemical series. And that's because the conditions we are using here are non-standard. So remember, when you've got the electrochemical series, those voltages are for standard conditions, and in the Leclanche cell, they're not standard conditions, so the voltage is different. So if you look in the diagram, you'll see that we've got manganese oxide there. That's important because it reacts with the hydrogen gas that's produced, and it prevents the build-up of pressure. If you didn't have that, then the hydrogen gas would build up and cause a lot of pressure, and obviously that would be an explosive hazard, and you don't want your batteries exploding. The water's there, although it's a paste, you've got a small amount of water there, and that allows the ammonia to dissolve, so it dissolves the ammonia given off, so again you haven't got the pressure build-up. So as a cell discharges, because the zinc is one of the electrodes, the zinc is used up, and the walls become thin and leak. So obviously this causes a problem. Now it's not as bad as it was in a Daniell cell because it's a paste rather than liquid, but it's still corrosive materials there, so it still causes a problem. So this is why it's important when you've got a battery that's been used up, you don't leave it in your electrical equipment, because otherwise the corrosive solutions can come out and cause damage to your electrical appliance. Now these sort of cells are best for equipment that needs a small current, but not continuously. So further examples of non-rechargeable cells are extra life batteries. So this uses zinc chloride as the electrolyte, and the advantage to this is you get higher current, and it's useful for radios, torches and shavers. So these give higher current than the Leclanche cell. The long life alkaline batteries are similar. They use an electrolyte of potassium hydroxide. The powdered zinc is used so that you get a higher current. And the advantages of these over the other non-rechargeable cells are it has a steel container, so that prevents leakage because it's more resistant to corrosion. It lasts up to 16 times longer, so it's longer life. And it's suitable for continuous high currents. For example, it says personal stereos in the textbook, so I've just written that. But obviously that's a bit out of date now. But any device that needs continuous high current, these would be useful for. The disadvantages of long life alkaline batteries are they're more expensive. And there's lots of choice of these long life alkaline batteries. You can have zinc, air, mercury oxide, zinc, silver oxide and zinc, and lithium and manganese oxide. And the way you choose which one you're going to use is looking at the voltage, the current, the size and the cost, and all of those will influence which battery you use for a particular purpose. So that was non-rechargeable batteries. Now rechargeable batteries. So rechargeable batteries, we recharge them by reversing the cell reactions. And you do that by applying an external voltage to drive the electrons in the opposite direction. So for example, lead acid is used in the starter motor of cars, where you've got sulfuric acid, the lead's coated with lead oxide, and you've got the negative plate with lead. And this is recharged when the engine's running, so the generator from the car recharges it. So examples of rechargeable batteries, you've got portable ones such as nickel cadmium. These are more expensive, but they can be charged up to 50 times, so they are quite useful. And then you've got lithium, which is used in things like mobile phones, cameras and laptops. And they're quite light because they're based on lithium rather than heavy metals, so their density is less. And they have the advantage that the polymer electrolytes means there's not going to be any leaks, so we don't have the problems that we had in the Daniell and the Leclanche cells and the non-rechargeable ones. And the voltage is higher than zinc and carbon batteries. So lastly, we're on to fuel cells, and it looks a complicated diagram, but you won't be asked to draw the diagram. And so these you'll be familiar with them from GCSE. So they use hydrogen and oxygen as fuel. You've got platinum-based electrodes, and the electrolyte is a polymer electrolyte which allows ions to pass through it, so the H+ ions can go through it. Again, they're non-standard conditions. You do need to know the half equations. The half equations are written there, and also the overall equation. Unlike the combustion engine, you don't get nitrous oxides forming because this reaction happens at low temperatures, and you only get nitrous oxides when the nitrogen and oxygen are going to react at high temperatures. So the advantages of the fuel cell is at the point of use there's no pollution. So when you're using the fuel cell, it doesn't cause any pollution. However, that doesn't mean there isn't any pollution caused by it, as we'll come to in the disadvantages. The only waste product is water, so you're making water, and obviously water's a good waste product to have because it's not toxic, and it's easy to get rid of, and it also has other uses. So in some cases, like astronauts, for example, have fuel cells, and they can then use the water that's produced as drinking water. So the other advantage is that it doesn't need to be electrically recharged. So unlike rechargeable batteries where you need to apply an external voltage to recharge them, the fuel cells don't need to electrically recharge. All you need to do is provide a continual source of hydrogen and oxygen, and it will keep going. The disadvantage of fuel cell is that most hydrogen, you get the hydrogen, most of it from crude oil. And as you know, crude oil is non-renewable, which which means it's eventually going to run out, so we won't be able to use it forever. And the other way you can get it is by electrolysis of water, but obviously electricity is generated by fossil fuels, or most electricity that we use is generated by fossil fuels, so therefore this causes pollution as well. So our lesson objectives, we'll go back to them, were to appreciate that electrochemical cells can be used as a commercial source of electrical energy, to appreciate that cells can be non-rechargeable or irreversible, or rechargeable, and you can also use fuel cells. You need to be able to use given electrode data to deduce the reactions occurring in non-rechargeable and rechargeable cells and work out the EMF of the cell. You need to understand the electrode reactions of a hydrogen-oxygen fuel cell and appreciate that fuel cells do not need to be electrically recharged, and appreciate the benefits and risks to society associated with the use of these cells, which is basically the advantages and disadvantages of these cells. So as usual, if you don't understand any of these, go back and either rewatch the video or look at the textbook. Make sure that you understand it before you come to lesson.